MotoGP is a rolling laboratory where every lap is engineered, measured, and pushed to the limit.
This lightweight carbon fiber shapes the bodywork for strength, speed, and airflow control.
Aerodynamic downforce stabilizes the bike under acceleration and braking.
At extreme speed, airflow becomes a measurable performance advantage.
MotoGP engines are prototypes built for power delivery, not mass production.
Electronics monitor grip, throttle, and wheel speed in real time.
Traction control helps manage torque when the tire is near its limit. Acceleration is controlled violence, power, balance, and software working together.
The tire is the final interface between prototype engineering and asphalt.
Telemetry turns every lap into a dataset. Speed, lean, braking, and throttle.
Carbon braking systems deliver extreme stopping power at racing temperatures.
Suspension keeps the tire loaded, absorbing forces while maintaining control.
Geometry, tires, and rider technique meet at the edge of traction.
Principles. Ride height systems help control squat and optimize acceleration off corners. Seamless shifting keeps the engine in the power band without losing time. Engine braking strategies help settle the chassis before turn-in. Rigidity and geometry allow instant changes without instability. Rider confidence starts with front-end feedback and predictable grip. At the limit, traction becomes a negotiation between rubber and torque. Straight-line speed combines engine output, aero efficiency, and stability. Every adjustment is measured: temperature, wear, and pressure.
Braking zones are where races are won in fractions of a second. Load transfer is physics on display, and engineers tune around it. Entry angle sets up everything that follows: apex and exit speed. At maximum lean, stability is everything. Exiting fast means finding grip while releasing lean angle. Aerodynamics can decide overtakes at the end of a straight.
Downforce helps keep the front stable when the brakes hit.
Engine maps shape power delivery to match grip and corner type.
Software helps keep the front down and acceleration clean.
Frame stiffness tunes feel. Too rigid and grip brakes, too soft and precision fades.
Controlled flex can improve traction by smoothing force spikes.
Cooling channels manage temperatures to keep braking consistent. Torque management keeps the rear wheel stable during downshifts.
The rider is the most adaptive system, balancing grip with movement.
Strategy and setup evolve lap by lap through data feedback.
In qualifying, prototypes are tuned for a single, perfect lap.
Race pace is repeatability, Technology supporting endurance at maximum speed.
The margin between grip and slide is measured in millimeters.
MotoGP is where prototype technology becomes speed, downforce, data, and daring fused into one machine.
Tiny changes in aero can alter stability, top speed, and tyre life.
Precision and control keep prototypes inches apart at extreme speed.
Temperature defines grip before the bike even rolls.
Even in prototypes, efficiency matters across full race distance.
Simple signals carry strategy, laps, gaps, and targets. Engine character is tuned for drivability as much as peak power.
Aero and chassis balance reduce wobble and increase confidence.
Overtakes are physics solved in real time.
Modern riding style exploits every millimeter of lean and grip.
The best setups calm the bike exactly when the rider needs it most.
Sensors feed the ECU, turning motion into decisions. Grip changes lap to lap as rubber builds and temperatures shift.
When conditions change, technology must adapt instantly.
In the wet, electronics and finesse keep the tire alive.
Braking becomes a controlled squeeze. Precision over aggression.
Between sessions, prototypes are rebuilt, measured, and refined. Precision manufacturing protects performance at extreme load.
The rider experiences speed as timing, brake, turn, throttle, repeat.
Technology makes proximity possible, control at the edge.
Controlled slides are part of modern MotoGP pace.
Aero helps keep acceleration usable, not wasted in wheelies.
Ride height control sharpens traction and straight line drive.
Keeping the front stable means more throttle sooner.
Power leaves the engine as heat, sound, and raw speed.
Speed becomes a visual language, lines, angles, and timing.
At this level, efficiency equals speed. The fastest machines compress reality into blur and sound.
Technology holds the margin, while riders push beyond comfort.
A race ends, but development never stops.
The true story is in the numbers, where time was gained and lost.
Every component exists to save time. Milliseconds stacked into victory. Even with technology, the final edge is human.
The noise fades, but the pursuit continues.
These machines are not products, they are experiments at speed. Development never ends. Engineers chase stability and speed in airflow.
Simulation helps predict behavior before the next lap begins.
The track holds the memory of speed.
Speed becomes a signature written in sound and motion.
Aerodynamics, brakes, tires, and electronics converge into one perfect corner.
MotoGP is the frontier of two-wheeled speed, where cutting-edge tech turns courage into lap time.